All right, let's talk about something that happens from time to time, which is source of a lot of headaches, but people usually don't pay attention to them. So what I have here is a very sophisticated drawing of PCB with two through-hole vias, right? And the red boxes here represent copper planes, right? It can be a copper pad onto a ground plane, or another copper pad onto a power plane, or another trace or a via, etc. The point here is that we're going to put this copper plane, this example, is for a QFN. So we're going to mount a QFN onto this pad, and the idea is that we're going to fill up this pad with solder paste, right? We're going to stencil a nice rectangle of solder paste that's going to be reflowed once the component's placed here. And here's what happened. The vias, the through-hole vias that you have there, they need to be plugged, right? They need to be plugged because if they're not plugged, what's going to happen? The solder, once it wets and gets into liquid form, is going to go get inside the via, right? But why is that a problem? Because that solder that you carefully calculated and measure, and you get the opening on the stencil, the thickness of the stencil, all the aperture on the stencil, if you're going to have windows or a whole window on the stencil, or tiny windows that are circular or square, rectangular, all that work you did to properly stencil solder onto your QFN pad is going to go down the drain, literally, because that solder is going to go into the via, and that solder you thought was going to be connecting your QFN to the board is going to disappear, creating a huge amount of voids. So let's see on an X-ray image what that looks like so that you can identify this problem, and then go back to your PCB manufacturing company and say, hey guys, I told you to plug all these vias on this pad and they're not plugged, so you gotta fix them, right? And then you're gonna have to have a conversation. If you have a bunch of these boards assembled, who's gonna pay for those components, which is a whole different conversation. Or for any reason, if you forgot to specify that those vias should be plugged, which then it's on you and you gotta figure out how you're gonna fix that. So let's see what that looks like on an X-ray image. Here's the component. We saw this in a previous video. We're going to use it again. These are the through-hole vias that we talked about, right? And this is how they look like when they're plugged. As you can see, there's no X-ray, solder inside, and I know that because I can see through the whole via, right? And I can see air on the other side. It's basically air inside the via because it's light, right? When it's dark like this, it tells me that there's solder in there, meaning that solder that should be on the board, should be on the component, got inside the via and filled it up when it shouldn't. So whatever mechanism you're using to protect those vias, solder mask, plug, whatever you're using to plug those vias so solder doesn't get in there, is failing on this component. And as a result, you end up with a lot of voiding that. So what's the problem of voiding on a QFN? Well, this QFN might need a certain amount of thermal impedance between this pad and the board for proper electrical impedance and for proper thermal dissipation, right? If this component is the die is producing or consuming enough power, and power is current times the voltage in the component. So if this component, if this die is demanding a lot of power, creating a lot of power, right, or sinking a lot of power, what are the three ways that the heat can be removed or transferred from the die to the external world? The three ways: radiation, convection, and conduction. There's very little radiation. The thing is encapsulated. Because it's encapsulated, there's no convection, right? There's no air, there's no fluids going through the component, the die, to dissipate this heat. The only way that you're gonna get heat out of the die is conduction. And the two paths of conduction for this die are the wire bonds going to the pads, and the back of the die going to this massive copper pad to dissipate onto the board, and then on the board you can connect to a ground plane, which is a massive heat sink, right? They can spread that heat all over the board, and then through air or even conduction, depending on how much power you're going to be pumping out of these components. The people who design these components, they don't rely on wire bonds for heat dissipation. They actually rely on this massive pad. So excessive voiding on this pad might cause the die to run much warmer than it should, which can cause performance issues and early damage or early death of your component, which is definitely nothing you want. So that's why voiding on a QFN is very, very important. It's something you have to check, and it's not, ideally not a spot check. If you can check all the components you're shipping, that's important to make sure you have the statistical process control, and that you don't have voids today, you might have voids tomorrow on the next board on, that you keep track and you realize what's happening in your line that might be creating this excess voiding. So anyway, that's about what we want to talk about via plugging and via filled with solder, and how that can be disastrous for your design. As usual, thanks for watching. Don't forget to subscribe, and if you have any suggestions, please let us know so we can address them in our future videos. Thank you.